Hello everyone. Welcome to the Q&A session for Toyota's batteries and carbon neutrality. I am Shuhei Hori, a moderator of this conference. First of all, please be advised that the conference is live broadcasting. In addition, the archived video and transcript will be posted on our website after the session. I'd like to introduce our speakers. Mr. Masahiko Maeda, Chief Technology Officer. Mr. Masamichi Okada, Chief Production Officer. Mr. Kenta Kon, Chief Financial Officer. And Mr. Keiji Kaita, President of Carbon Neutral Advanced Engineering Development Center. Now I would like to hand over to Mr. Maeda.
Hello everyone. I'm Masahiko Maeda, Chief Technology Officer of Toyota. First of all, I will turn it over to interpreters to introduce our presentation.
Today, I would like to talk about Toyota's development and supply of batteries toward achieving carbon neutrality. First, using industrial products as an example, carbon neutrality means reducing CO2 emissions to zero throughout the entire life cycle of a product, starting from procurement of raw materials, manufacturing, and transportation to use, recycling, and disposal. As you all know, the world's concentration of CO2 has been increasing since the Industrial Revolution. There is no time to lose when it comes to reducing, in all aspects, the amount of CO2 emitted by humankind. For example, according to our calculations, the CO2 reduction effect of 3 hybrids, HEVs, is almost equal to that of 1 BEV, BEVs. At the moment, because we can provide hybrids at a comparatively affordable price, in places where the use of renewable energy is to become widespread going forward, electrification using hybrids is among the effective ways of reducing CO2 emissions. On the other hand, Toyota believes that the increased use of zero-emission vehicles, or ZEVs, such as BEVs, and fuel cell electric vehicles, or FCEVs, is important in regions where renewable energy is abundant. Furthermore, in some regions, such as South America, bioethanol has been put to practical use as a response to CO2 reduction. As mentioned above, we should focus on how to avoid carbon emissions, or on how to reduce them to as close to zero as possible. Because the options for reducing CO2 emissions depend on the energy situation at hand, Toyota will continue to try various measures to expand the options for achieving carbon neutrality. With this in mind, Toyota is preparing a full lineup of electrified vehicles. We want to provide sustainable and practical products that reduce CO2 emissions while considering the convenience of our customers in each region. First of all, please allow me to look back on Toyota's electrified vehicle achievements to date. Since the introduction of the first-generation Prius in 1997, Toyota has also introduced plug-in hybrids, FCEVs, and BEVs, while also improving performance. Among such, our cumulative sales of hybrids have now reached as many as 18.1 million units. Earlier, I mentioned that the CO2 emissions reduction effect of 3 hybrids is equivalent to the reduction effect of 1 BEV, and the 18.1 million hybrids sold to date are equivalent to the CO2 reduction effect of introducing to the market about 5.5 million BEVs. The volume of batteries for hybrids that we have produced so far is the same as that of the batteries installed on about 260,000 BEVs. In other words, we can say that the batteries needed for 260,000 BEVs have been used to achieve the CO2 emissions reduction effect of 5.5 million BEVs. In the future, in light of changes in the market, we will also accelerate the introduction of BEVs and plug-in hybrids, leveraging the strengths we have gained through our experience so far. And we will strive to reduce CO2 emissions by increasing the selection of electrified vehicles we offer and having customers in each region choose us so that we can accelerate the dissemination of electrified vehicles. The 3 core technologies that support this full lineup of electrified vehicles are electric motors, batteries, and power control units. Today, in this context regarding batteries, I would like to share with you Toyota's unique approach and the competitive edge that we have developed via the mass production of electrified vehicles. While promoting a full lineup of electrified vehicles, we have also been developing and manufacturing a full lineup of batteries. For hybrids, our focus is on power output, or in other words, instantaneous power, while when it comes to plug-in hybrids and BEVs, our focus is on capacity, or what can be called endurance. As batteries for hybrids, we have been continuously evolving nickel metal hydride batteries and lithium-ion batteries by taking advantage of their respective characteristics. Our bipolar nickel metal hydride battery, which was announced this year and is focused on providing instantaneous power, will be used in an increasing number of vehicles. For lithium-ion batteries for plug-in hybrids and BEVs, we have been striving to improve both cost and endurance, and we will continue to improve them as we move forward. We are developing a further advanced new type of lithium-ion battery for introduction in the second half of the 2020s. From here, I would like to explain something that Toyota values in its development of batteries. What Toyota values the most is to develop batteries that its customers can use with a peace of mind. Especially, we are focusing on safety, long service life, and high-level quality to produce good, low-cost, and high-performance batteries. For example, longer service life also affects a vehicle's residual value. In terms of cruising range, high energy density and high-level performance are also necessary. We want to make the charging speed faster, but too fast will affect safety. Therefore, we think it is important to strike a balance between each of these factors to ensure safe use. This concept has remained unchanged since batteries were installed in the first generation Prius, and it is the same for the batteries in all of our electrified vehicles. By applying the technology that we have cultivated through our experience in batteries for hybrids, also to the batteries for future BEVs, we believe that we will be able to deliver batteries that can be used with a peace of mind. Now, I would like to introduce 3 examples of the many efforts required to produce batteries that can be used safely, using lithium-ion batteries as the focus of my explanation. This is an example of ensuring safety. It is known that each battery cell shows signs of localized abnormal heat generation during spirited driving or other driving that places a large load on the battery. By analyzing the phenomena occurring inside the battery and conducting a vast amount of model experiments, we have been able to clarify the effect of driving style on the battery, as well as the mechanism of this effect. Based on the results, we have been able to detect signs of abnormal local heating of cells through multiple monitoring of voltage, current, and temperature of individual cells, blocks of cells, and the entire battery pack. The battery is then controlled to prevent abnormal heat generation. We will maintain our concept of ensuring safety, security, and reliability down to the local areas of each battery, even when it comes to BEV systems, and we will continue to refine that concept. The second example I would like to share with you is our commitment to long service life. We have applied the technologies that we have cultivated through the development of batteries for hybrids to plug-in hybrids, and the batteries in the CHR BEV have a greatly higher capacity retention rate after 10 years than the batteries hitherto used in our plug-in hybrids. Furthermore, for the Toyota BZ4X, which is scheduled to be launched soon, we have set a target of 90% endurance performance, which is one of the highest in the world, and we are currently finalizing our development efforts to achieve it. I would like to introduce some examples of the developments that we are working on to achieve long service life. From a detailed analysis of the inside of lithium-ion batteries, we know that degraded materials on the surface of the anode have a significant impact on the life of a battery. To suppress the generation of these degraded materials, we are clarifying the generation mechanism and taking measures in various aspects such as material selection, pack structure, and control system. careful implementation of detailed analysis and an accumulation of countermeasures has led to improved endurance performance. The third example has to do with our efforts for achieving high-level quality. If metallic foreign matter enters the battery during the manufacturing process and directly connects the anode and cathode electrically, there is a possibility of failure. We confirmed that foreign materials and its effect on endurance, and also its effect on batteries. Based upon this, we are being extremely attentive to the size and shape of foreign matters and are managing processes in order to prevent the generation or entry of these foreign matters. What I explained are only a few of the things that we are doing, but with this kind of steady and meticulous analysis, and with the experience gained from the feedback of 18.1 million units in the market, we will continue to deliver batteries that can be used with peace of mind. Next, I would like to explain the bipolar nickel metal hydride battery used in the new Aqua announced in July this year. We co-developed this battery with Toyota Industries Corporation and commercialized it as an onboard battery for driving. Compared to the batteries used in the previous generation of the Aqua, the output density is double, giving the car a powerful acceleration sensation. As for batteries for next generation BEVs, the BEV technologies that we've gained since our 1996 launch of RAV4 EV and the latest battery and electrified vehicle technologies that we have cultivated through HEVs or hybrids have been reflected into the Toyota BZ4X and will soon be introduced to the market. From now, I would like to explain about the batteries of the future. To popularize BEVs, we would like to reduce costs so to provide BEVs at a reasonable price. So to start with, we aim to reduce the cost of batteries themselves by 30% or more by developing materials and structures. Then, for the vehicle, we aim to improve power consumption, which is an indicator of the amount of electricity used per kilometer, by 30%, starting with the Toyota BZ4X. Improved power efficiency leads to less battery capacity, which will result in a cost reduction of 30%. Through this integrated development of vehicle and batteries, we aim to reduce the battery cost per vehicle by 50% compared to the Toyota BZ4X in the second half of the 2020s. Please allow me to explain the coming next generation batteries. For liquid batteries, we will take on the challenge of material evolution and structural innovation. We'll also aim to commercialize all solid-state batteries. As you can see, we'll develop 3 types of batteries, and by the second half of the 2020s, we hope to improve the characteristics of each type so that we can provide batteries that can be used with peace of mind. Next, I would like to explain our initiatives related to all solid-state batteries. We are developing all solid-state batteries to see if we can realize high output, long cruising range, and shorter charging times. In June last year, we built a vehicle equipped with all solid-state batteries, and we conducted test runs on a test course and obtained driving data. Based upon this data, we continue to make improvements, and in August last year, we obtained license plate registration for vehicles equipped with all solid-state batteries and conducted test drives. There are some things that we have learned during the development process. All solid-state batteries are expected to have higher output because of the fast movement of ions within them. Therefore, we want to take advantage of the favorable properties of all solid-state batteries by also using them in hybrids. On the other hand, we found that short service life was an issue. To solve these issues, we need to do further development of solid electrolyte materials. We feel that having identified an issue has brought us to one step closer to commercialization. The establishment of battery supply system is also important for the dissemination of BEVs. With the rapid expansion of electrified vehicles, we are working to build a flexible system that can stably supply the required volume of batteries at a required timing, while meeting the needs of various customers in each region around the world.
in pursuit of a battery development concept of achieving batteries that can be used with peace of mind, we'll establish the needed technologies through a certain amount of in-house production, and will cooperate with partners who understand and will practice our concept. We'll also proceed with discussions with new partners in some regions. We're building a system with our partners that will allow us to incorporate into discussed plans the volume of batteries that we'll need in about 3 years. Within the Toyota Group, we are also working to shorten the lead time for the startup of production and to establish a system that is adaptable to changes. This summarizes our development and supply of batteries by 2030. In development, we will aim to achieve a per vehicle cost of 50% or less compared to now through the integrated development of vehicles and batteries. In terms of supply, we'll respond flexibly to the changing needs of our customers. For example, we assume that we will exceed 180 gigawatt-hour worth of batteries that we are currently considering, and will be ready with 200 gigawatt-hour worth of batteries or more if the dissemination of BEVs is faster than expected. The amount of investment in the development of battery supply system and R&D is expected to be about 1.5 trillion yen by 2030. By establishing a system for both development and supply, we will promote the dissemination of electrified vehicles, including BEVs. On the way to our goal of achieving carbon neutrality in 2050, the energy situation and infrastructure of each region, as well as the sensibilities and convenience requirements of customers, will continue to change. When it comes to electrified vehicles, cars and batteries cannot be separated. Toyota, which has been committed to producing batteries within the Toyota Group since 1997, and whose market-introduced hybrid alone number 18.1 million unit, is an automaker that has been working on battery development as a corporate group. And into the uncertain future of electrified vehicles as well, it intends to move forward in sure-footed steps. Thank you.
To adapt to the future sustainably and practically, Toyota would like to contribute to the achievement of carbon neutrality by improving its adaptability to change and its competitiveness, as well as by aiming for the fundamental widespread acceptance of ever better electrified vehicles. That's our presentation. We are now ready for the Q&A session.
Thank you, Maeda-san. We are now ready to take your questions. We'd like to receive questions from as many people as possible, so only up to 2 questions per person, please. Further questions may be possible later if time allows. If you have any questions, please display your company name and your full name in Zoom. Then press the raise hand button on the screen. When I'll call your name, please unmute your line. Please understand in advance that we are not able to identify the participants on the phone, and therefore we are unable to take questions over the phone. Also, since your questions will be translated consecutively, not simultaneously, please try to keep your questions brief. Thank you for your cooperation and understanding. So now I'll open the floor for questions. Okay, our first question from the Domini, Ms. Sekiguchi. It's your turn, so please wait a moment while we switch lines. So please.
Can you hear me okay?
Yes, I can hear you.
Okay. Thank you. Well, thank you so much for this opportunity. And my name is Shoko Sekiguchi with the Domini Impact Investment, New York-based asset manager. And I have 2 questions. One is I appreciate that presentation about long service life of a lithium battery. But my question is that Do you have any sort of the program to recycle the battery? Because degradation is cannot be avoided for a while. I understand Nissan, for instance, launch joint venture called 4-Hour Energy that focus on recycling leaves battery. And I was wondering if you have the kind of program in the future. And the second one is do you have any charging stations initiatives? That would be another very important strategy. So I'm just wondering about 2 questions. Thank you very much.
はい、ご指名ありがとうございます。ニューヨークに拠点を置いていますアセットマネージャーをしています関口翔子と申します。2つ質問がございます。1つ目はプレゼンテーションの中でリチウムイオンバッテリーの長い寿命を目指していくということが説明されていました。これは非常にいいことだと思っています。しかし質問としましては今後バッテリーをリサイクルするようなプログラム、こうしたものに取り組む計画というのはあるでしょうか。なぜならば今後規制の強化というのは避けられないと思います。そして例えば日産では 4-Hour Energy というジョイントベンチャーの取り組みを開始しています。ここでリーフのバッテリーのリサイクルを行っていくプログラムを開始したと説明をされています。トヨタも同様のプログラムを将来準備されていくような計画はあるのでしょうか。2つ目の質問です。今後は充電ステーションなどの取り組みも計画されているのでしょうか。今後の重要な戦略の一つと考えられると思いますが、こうしたことも計画されているでしょうか。
1つ目いきます。ご質問ありがとうございます。最初の質問に前田より回答させていただきます。トヨタのハイブリッドを販売してきた歴史が約20年以上経ちます。
Thank you. For your first question, myself, Maeda, would like to respond. First of all, Toyota has more than 20 years of history in selling hybrid electrified vehicles.
我々が電池のリサイクル、またはですね、リユースとかリビルトを考えるときに、いかに回収するかというのがあると思います。
When Toyota thinks about the recycling, reuse, or rebuilding of batteries, we need to think on how to collect those batteries.
このハイブリッドの20年以上の歴史があるんですが、現時点で、トヨタが回収できている電池は実はそう多くありません。
And so, as I said, Toyota has more than 20 years of history selling hybrids. However, currently, Toyota has not been able to collect so much of the batteries that have been sold.
電池の寿命が長くなるということは、同時に車の寿命が長くなるということでもあると思っています。
When we talk about having a longer service life of batteries, this will also mean that the life of the vehicles will become longer as well.
なので、我々は電池の寿命が長くなったときに、いかに回収をするのかということを、まずシステム化しなくてはいけないというふうに考えています。
Therefore, when we think about enlonging the life of the battery, at the same time, we'll have to think of how to establish a system to collect those batteries.
現時点でそれに関する詳細な計画はありませんが、例えばリースを電動車では比較的積極的に使うというようなやり方で、電池がもしくは車がですね、トヨタのところに戻ってくるというようなことも考えられるのではないかと思っています。
Currently, we do not have a detailed plan in order to do this. However, for example, we can think about a lease program where the electrified vehicles can be more proactively used for leasings, and then consider the batteries or the vehicles that is leased to be returned and collected in Toyota.
日本では家電リサイクル法というのがあって、いわゆる電気製品のリサイクルが法制化されています。例えばこういったやり方で電池を回収するような仕組みを作るというのもあるかもしれません。
Also, in Japan, there is a recycling law for house appliances, home appliances, and therefore, this kind of an approach of having a enforced law regarding, for now, it's about the electrical appliances, but creating such a similar system for the batteries may be one option to consider.
こうしたどうやって回収するのかということを考えながら、同時に、もし回収できたときに、車両の構造をですね、回収しやすいように今から設計するというのはあると思っています。
In addition to considering about how to create a system to collect and recover the batteries that we have sold, at the same time, I think it is important to consider a design approach as well about designing the vehicle structure so that the recycling or collection of the batteries will become more easier in the future.
一つ目の質問の回答は以上です。
So that will be the response to the first question.
回答します。じゃあ続きまして2つ目の質問について回答いたします。充電ステーションの戦略ということですが、現時点で、大規模のその充電ステーションをトヨタ独自で準備するというような計画はありません。
So I'll go on to respond to your second question as well. So this second question was about the charging station strategy. Currently in Toyota, we do not have our own unique plan to create a large-scale charging station ourselves.
一方でトヨタには我々と一緒にカーボンニュートラルを支えていこうという協力していただける販売店の方々がたくさんいます。
And on the other hand, for Toyota, we do have many dealers that work with us and cooperate with us, trying to contribute in achieving carbon neutrality targets.
こういった販売店の方々と一緒になってですね、少なくとも日本では販売店に充電ステーションは設置が始まっています。
So working together with dealers, at least in Japan, we have started initiatives to work on establishing the charging station infrastructure in Japan.
なので将来電動車がもっと普及する状態になったときに、この販売店の方々とどうやって充電ステーションを広げていくのかというのが今後のポイントになると思っています。
Therefore, in the future, when we see that the electrified vehicles are much more popularized in society, I think the next key point for us is to work with dealers and think about how we can expand this network of charging stations.
この充電ステーションをやるときにもう一つ重要なことがあると思っています。
And I think that there is another important point when we think about the charging stations.
おそらく皆さんがガソリンステーションに行ったときに、いわゆる給油ができなかったという経験はほとんどないと思います。
Probably when you think about your own experience, if you visited the gasoline station, you probably never have experienced of not being able to fill up your car with gas.
同様に充電ステーションをやるときに、やはり充電ができないという状況がないように、いかに環境を整えるのかというのも大きな課題というか重要なことだと思っています。
And that similar experience needs to be replicated with the charging stations as well. In other words, we should avoid a situation where our customers visit a charging station but are not able to charge their vehicles. So how to set up an environment that will allow the users to always be able to charge the cars, charge the vehicles, will be our challenge or an important thing that we must think about.
例えば支払いのカードのマッチングが合わないだけで充電ができないというようなことが日本ではあります。
To give you an example, there has been cases in Japan where at the charging station, the customer was not able to use their credit cards for the payment since it didn't match this payment system. They were not able to charge their vehicle.
例えば充電器と車の充電機能の相性が合わなくて 充電ができないということも実際には発生しています。
And there has been actual experiences with the customer where the charging station and the vehicle's charging function did not match well, and therefore the customers was not able to have their car charged.
我々が充電ステーションを販売店の皆さんと一緒に設置していくときに、こういった課題もないようにサービスを考えていくということも重要だと思っています。
So when we work with dealers about setting up the charging stations, we will need to take care of these issues and be able to provide the services that will be not having these kinds of issues.
以上で回答終わります。
That will be my response to your questions. Thank you.
Thank you very much, Sekiguchi-san. So next question comes from the chat. I'd like to introduce that from the Fidelity Lucille Lolo. Thank you very much for the presentation. I have two questions. Question one, you mentioned a decreased battery cost by 50% by 2025. Can you please give some color of where you see your current battery cost? Question two, out of the 1.5 trillion yen you plan to spend on batteries by 2030, how much will be allocated to solid-state batteries? Many thanks.
では次の質問はフィデリティのロルさんからチャットでいただいております。2つ質問がございます。1つ目は2025年までにバッテリーのコストを 50% 下げるというお話をいただきましたけれども、現在のコストはどのような水準にあるのかということを少し感触を教えていただければと思います。2つ目の質問は2030年までに 1.5 兆円の投資をされるということでしたけれども、このうちどれぐらいを全固体電池に向けられるのかということを教えてください。
Okay, this is Kaita, and thank you very much for your question. For the first question for you, I'll answer that maybe we have the electrical vehicle launched the year before last. That is maybe from that cost, maybe next year we'll launch the so-called electrical vehicle in China or the world. And maybe the battery cost will be reduced up to 40%. And then from that electrical vehicle, maybe in the latter part of the 2020, we'll reduce the battery cost to at most 50. And maybe the 50% is accomplished maybe both of the improvement of reducing the drag or maybe rolling force of the vehicle, but also the battery cost itself. And mainly the battery cost is coming from the material improvement and maybe a structural improvement, including the battery cell and the battery pack. And the second question.
じゃあ2つ目の質問について回答します。どれくらいの投資をですね、全固体電池に振り分けるのかという質問ですが、現時点でそれが明確にいくらというふうに決めているわけでも決まっているわけでもありません。
I would take the second question. Well, I think your question was about how much of this total investment will be allocated to all solid-state battery. And my answer is that we have not decided a clear level or clear number for such allocation at the moment.
この 1.5 兆円のうち約5000億がですね、開発にかかる投資になるんですが、その中には全固体電池だけではなくて、いわゆる液系のリチウム電池の次世代の開発というのも含まれております。
Out of 1.5 trillion yen, 500 billion is an investment for development. But this is not only for all solid-state battery, but it also includes the investments or the development for the next generation liquid type lithium-ion batteries too.
これらの開発をやるときに、もちろん一部の材料開発などはですね、全固体は全固体、リチウムはリチウムという液系は液系というようなやり方もしますが、それ以外共通で開発するような要素もあります。
When we go through the development, of course, for some material development, there are separate development uniquely for all solid-state batteries or lithium-ion batteries, and also liquid batteries, respectively. However, there are some common development elements too.
今年の7月に日本でアクアというハイブリッドカーを登場させました。モデルチェンジしました。
This year in July in Japan, we launched a model change version of Aqua, which is a hybrid car.
ここで使われている新型のバイポーラという構造の電池は、グループのトヨタ自動織機で開発されたものです。
This car carries a new type of bipolar battery, and this was developed jointly together with Toyota Industry Corporation.
このようにですね、トヨタがグループの会社と共同開発するということも含めて、いわゆる延べ5000億というふうに理解をしていただきたいと思います。
So please understand this 500 billion yen would include some of such joint development with companies within the group companies, so within the Toyota Group.
でその中でグループで共通で開発できるところ、それぞれが開発するところというふうになっておりますので、そういったやり方で効率よく開発していきたいというふうに思っております。以上です。
There will be some joint development within the group, or there will be some unique development by each company. And through such ways, we would like to pursue efficient development process. Thank you.
Thank you very much. So we'll go to next questions. NWQ, Mr. Peter Boardman. So it's your turn. Please wait a moment while we switch lines. So Peter,
hi, thank you.
Yep.
Can you hear me? Okay,
yeah,
thank you.
I can hear you.
I have two questions. First of all, could you give us of the 1.5 trillion yen investment in batteries, could you give us a breakdown by region? Given United States NAFTA and local content rules, what is your outlook for U.S. investment? I think most of your batteries are made like in China with CATL and also Pan-Pacific with Panasonic in Japan. But are there plans to build batteries in the United States? And then also in China, what is your expectations for battery production? And the second question is regarding chip shortages. Today, it seems as though, I know Toyota has been talking about recovering in production with the chip shortages, but is your EV strategy being delayed at all because of lack of inability to source materials such as wire harnesses and semiconductors? Thank you.
はい、NWQ のピーター・ボードマンからの質問、2つの質問があります。1つ目の質問は、先ほどからお話ししている 1.5 兆円の投資に関して、バッテリーへのこの投資の地域ごとの内訳をお話しいただけるでしょうか。アメリカでは NAFTA ですとか、現状化、ローカルコンテンツのルールなどがございます。アメリカの投資計画というのはどのようなことになっているでしょうか。今、トヨタではほとんどバッテリーは中国で、CATLとともに生産していたり、あるいは反太平洋地域においてはパナソニックとの取り組みがあると思います。この状況でトヨタはアメリカでの生産計画というのも持っていらっしゃるのでしょうか。また中国のバッテリーの生産計画についてもお聞かせいただきたいと思います。2つ目の質問です。今現在半導体不足の問題が発生していると思います。そして現在ではトヨタは生産が回復傾向に向かっていると説明されていたと思 思いますが、この半導体問題で、電動化車両の戦略に対して何か遅れが発生していることはあるでしょうか。特にこの材料調達の面でワイヤーハーネスであったり半導体の調達に問題が起きている、影響があるというようなことはあるでしょうか。
はい、それでは岡田の方からご説明いたします。
Thank you for your question. Myself, Okada, would like to explain.
まず一つ目のご質問に対してですけども、まずもってグローバルに私どもは2030年までに 1.5 兆円、生産ラインにして、ベブ用として70ラインを構えていく予定でございます。
Starting with your first question, so Toyota's plan is to make a 1.5 trillion investment until up to 2030 globally for the production lines. And for the production lines dedicated for BEVs, we are thinking of adding 70 lines.
この各地域でどのように生産をするかということになってきますと、これはまずもって私どもはいわゆる内製グループで受け持つところ、それから前田のプレゼンテーションにも出てまいりましたように、多くのパートナー企業の皆さんと各地域での供給をしていく計画を現在遂行しているところでございます。
And to elaborate, to talk about the production plans for each region, first of all, Toyota will have our in-house group companies that we work with to create plans for the production. And as it was included in the presentation of Maeda-san, we have also many partner companies that we will be working with to create a plan, a supply plan in each region. So these plans are being discussed among with these companies.
従いまして基本的な考え方としましては各地域地産地消という考えですから、米国においてもまた中国においてもヨーロッパにおいても基本的に同じ姿勢で取り組んでまいります。
And basically, our policy is to do local production and local consumption. So following this policy, regardless of the region, whether it is US, China, or Europe, we will take the same approach of same way of thinking, local production, local consumption.
いずれにしましても2030年に向けてトヨタは電動車を積極的に展開してまいります。それに供給する電池については今申し上げたように地産地消を前提に積極的にこれも材料調達、それから生産ラインの構築、これをパートナー企業と一緒になって進めてまいります。
In any case, toward 2030, Toyota will be proactively developing our supply of electrified vehicles. And for the batteries that will be supplied for these vehicles, we will be working with this approach or concept that I have said, local production, local consumption. And this will cover the material procurement and also the setting of additional production lines too. So we will be proactively engaged in these development activities with our partners.
それから2つ目のご質問に対してですけれども、半導体に関しては私ども長年のサプライヤー様との信頼関係を構築してまいりまして、非常に厳しい中でもなんとかその影響を小さくしてくることがこれまではできました。
Now, going on to your second questions about the chips, the semiconductors. Here, we have been able to build a trust-based relationship throughout long years with our suppliers. Therefore, even though we are under a very tough situations, we have been able to keep the impact of the chip shortage issues small up to this day.
しかしながらそれにもやっぱり供給側の能力上のやっぱり限界もございます。そういう意味で影響が出ておりますけれども、これについてもサプライヤー様と連携をしっかりとって今後供給についてもより安定化していくという方向ではございます。
However, saying that, of course, there are limits in the supply capacity as well. So there will be some impact to Toyota as well. However, also for this issue, we are working closely with our suppliers so in order to stabilize the supply situation as quickly as possible.
そういう方向ではありますけれども、これにもともとの半導体不足に加えまして、昨今のアジアにおけるコロナの蔓延の影響が強く出ておりまして、これは自動車業界全体に影響が出ておりますけれども、この影響はまだまだ予断を許しませんので、引き続きしっかり連携をとって、その最小化、それからその後の挽回に向けていきたいというふうに取り組んでおるところでございます。
So that will be the basic direction that we are working on. However, in addition to the chip shortage that has happened originally, in addition to that, we are now seeing the impact coming from the spread of COVID-19 in the Asian regions. So this is an impact that is caused to the total auto industry. And therefore, we still need to work we will continue to work with our partners for these issues as well in order to recover the situation.
以上です。
That will be my response. Thank you.
Okay, thank you, Peter. So we will move on to next questions. So Matthews, Mr. Dong-Eun Han. So it's your turn. Please wait a moment while we switch lines.
Hi, can you hear me?
Yes, I can hear you.
Great. Thank you so much for your presentation today. I have two quick questions. The first question is, so you guys are expecting 200 gigawatt this time, but previously this used to be 180. So, but your VV target assumption is actually not changed. So in terms of raising that battery capacity target, can you just elaborate what kind of assumption has changed, whether that's regional mix or just general underlying assumption? That's the first question for me. The second question is just CapEx intensity seems fairly low. 1.5 trillion divided by 200 gigawatt is only 7.5 billion per gigawatt, and that's fairly low compared to what peers have announced. And also, when we think only 1 trillion of that is from production capacity, so it seems very efficient. Does that mean that you guys are pushing, a lot more JV format going forward? Can you just elaborate on that high efficiency and whether that is sustainable? Thank you very much.
私の方からは2つ簡単な短い質問がございます。本日ですね、200ギガワットを予測していらっしゃるとご発表いただきました。確か今年の早い段階ではこの数字は180だったと思います。その一方でBEVのですね、予測ターゲット数は変わっていないと思いますので、どのような前提の変更によってこの180から200ギガワットへと変わったのか、地域ミックスなのか、それとも前提そのものが変わったのかということを教えてください。そして2つ目ですけれども、この設備投資のインテンシティということで、非常に効率的な数字だと思います。この 7.5 ビリオンをですね、1ギガワットあたり 7.5 ビリオンという数字になっておりまして、この数字は他社と比べても非常に低く、またこの設備投資だけで考えると1兆円ということをお聞きしましたので、非常に数字が低い、つまり効率的だと思います。これはジョイントベンチャーの仕組みをさらに推し進めていくことによって実現できるのか、この非常に高い効率性についてご説明いただければ助かります。
はい、それでは1つ目のご質問からお答えします。
Okay, I will respond to the first question.
5月頃の段階で180ギガワットという発表をさせていただきましたけれども、その後の具体的な検討を進めていくこと、それからアメリカなど各地域のその後の状況変化などを踏まえた上で、200万台のBEV、それから FCEV、それから800万台の電動車、 これを確実にお届けしていくのに必要な電池の量、これをもう一度検討し直した結果、200ギガワットは最低必要であろうというところへ来た結果でございます。
So the first question was about we announced 180 gigawatt hour at the time of May, and after that we made a more detailed discussion, and based upon the situational changes in many regions, including the United States, and in order to supply 2 million units of BEVs and FCEVs, and also 8 million units of electrified vehicles in total, if we want to be sure to deliver these units, we thought that we would need a larger volume of batteries. And based upon these numbers, we thought that 200 gigawatts will be necessary.
このような変更というのは今後もおそらくあると思っています。これはやはり各地域の電動車の規制や、それから地域のお客様のニーズ、それからインフラの状態、こういうものがやはり変化してまいります。従いまして、私どもが200万台、800万台という電動車、それから EV、それから FCEV、この数字を基準としてお示ししておりましたが、この数値そのものもそうですし、それから各地域への配分についても、今回もまさにそうですけども、この点については今後も変化がある。それにやっぱり柔軟に対応して、スピーディーにお届けしていくということだと思っています。
And we do expect that these kind of changes will occur also in the future. There will be some changes in the regulation and the legal status of the electrified vehicles in each region, and also customer needs and infrastructure status would change as well in the future. We did say that our baseline would be 2 million of BEVs and FCEVs, and also 8 million of electrical vehicles in total. But these are also likely to, they could change, and also the allocation to each region would also might change. And we would need to flexibly cater to those changes in order to speedily deliver those units to customers.
2つ目のご質問に対してですけれども、設備投資につきましては、私どもは小さな減単位といいまして、1ラインあたりの生産量、それからその1ラインあたりの投資額で、1ラインあたりに関わる要員の数、そして生産ラインを作っていくリードタイム、こういうのを私ども減単位と呼んでますけれども、これをできるだけ小さくする努力をしております。
Now, with regards to the second question about the capital expenditure, we pursue what's called small base units. Base unit means the production volume for each line, or investment amounts per each line, or the staffs involved working in each line, as well as the lead time to create each production line. We call those things base units, and we try as much as possible to minimize these base units.
これは、トヨタ自動車が車作りをしてきた中で、長年このような考え方でラインを作ってまいりましたし、電池におきましてもこの20年余りのハイブリッド用の電池のラインの作っていくにあたって全く同じ考え方で進めてきておりまして、これを今後のより広がっていく電動化にもつなげていくということでございます。
Toyota has been making cars based upon this concept, and this concept will also be applied. has also been applied to the production lines of hybrid, or the battery lines of hybrid, which we've been producing in the past 20 years. So I think this will be connected and relevant also in the electrification, which will be bigger in the future.
でこれは主にトヨタおよびそのグループのいわゆる内製ラインに対してこのような取り組み方をしていくということと、それに加えて、パートナー企業のそれぞれのこちらはもう電池の専門メーカーであり、もともとの強みを持っていますから、こういうところとしっかり組んでですね、お互いの強みをしっかり出し合って、結果的にはお互い切磋琢磨をしていい電池を作って競争力ある電池を作って車を作っていくと、こんな形で実現していきたいと思っております。
So this initiative will be applied to the in-house line of Toyota and Toyota Group, but also we'll be working with the partner companies who are the experts of battery making, and they have their original strength. And by collaborating with these partner companies and also by exhibiting each other's strengths, we would like to improve each other's capability so that we can come up with more competitive batteries and more competitive cars.
以上です。
That is all.
Thank you, Dong-gun. We'd like to move on to the next question. So, from Church of England, Miss Claire Richards, it's your turn. So, please wait and unmute. Okay. So,
hello.
Hello. Yep, I can hear
you. Hello. So the Church of England Pensions Board, thank you very much for the presentation today. There are two aspects from the end of the presentation I just wanted to touch on. So one was where you said that the energy situation and infrastructure of each region will continue to change. And the second one, soon after, that Toyota is aiming for the fundamental widespread acceptance of ever better electrified vehicles. And my question is what role Toyota sees for itself in terms of responsible advocacy and lobbying in order to make those conditions a reality?
はい、チャーチ・オブ・イングランドペンションファンドのクレア・リチャーズから質問させていただきます。プレゼンテーションありがとうございました。プレゼンの内容から2つ確認したいことがございます。1つおっしゃっていたことは、今後もエネルギーのインフラであったりエネルギー状況は変わり続けていくという点をおっしゃったのと、それから2つ目、トヨタとしても今後より良い電動車両を出していき、それがお客様に受け入れられるように取り組んでいく、それを期待したいという話がありました。このことにおいてトヨタの役割というのをどう考えていらっしゃるでしょうか。言い換えてみればトヨタがそういった状況になれるようにどのようなアドボカシー活動ですとか説明責任、どのような責任を果たしていく、あるいはまたロビー活動などにおいてどのような役割をトヨタが担うことになるとお考えでしょうか。
ご質問ありがとうございます。今の方からご回答申し上げます。
Thank you for your question. So, I'm Kon. I would like to respond to your question.
後ほどまたエンジニアリングのメンバーからも補足をさせていただきますけれども、トヨタとしても今後より BAB を出すっていう話をさせていただきました。やはり私どもは、特に日本ではグローバルにおいても自動車のリーディングカンパニーでありますので、非常にバッテリー B に注力をしていく非常に大きな責任があるというふうに思っております。
So probably after my response, the engineering group members will provide an additional comment, but I'll start anyway. So for Toyota, we have explained that we are going to proactively work to be able to supply BEVs further in the future. And especially in Japan, we are a leading company in the automobile industry. Therefore, because of this position, we think that we have a big responsibility in working to promote BEVs.
それに加えまして、各私どもグローバルのさまざまな地域でビジネスを行っています。で、各地域の状況に合わせたカーボンニュートラル、CO2 削減に向けて各地域にとって適切な方法を取っていくということも我々にとって必要なことであります。
And in addition to that, we conduct business in all parts of the region globally. Therefore, in each region, according to the situation that each region has, we think that we need to take the appropriate measures for each region toward carbon neutrality and also to reduce carbon CO2 in that region. That will be also a necessary initiative for us to take.
で最終的にはもちろん、カーボンニュートラルというのはメーカーだけでやっていくことではありませんので、我々が果たすべき役割、あとは、国、あとはその消費者、みたいな方々が果たすべき役割、それぞれをしっかり果たしていくことがつながっていくと、そういうことに対して我々は責任を持っていきたいというふうに思います。
At the end, for carbon neutrality targets, one maker like us will not be able to achieve those targets alone. So we think it's important that we play our own role, and then there are things that the national government needs to do, and also there will be some of the contributions from the consumer side. So everyone in each of their positions will take their actions, and I think at the end it will all combine together. So in that sense, we will have responsibility to play our role.
最後にあったロビー活動についても、今年の春にですね、お約束をしました通り、今年度ロビー活動に私どものロビー活動に関する開示について現在準備を進めているところでございます。以上です。
And finally, you did mention about the lobbying activities for Toyota. In spring, we have made a commitment that we will disclose our lobbying activities plans or report for this fiscal year. And therefore, we are now preparing that disclosure or that report. So that will be all for my response.
前田より少し技術的な補足をさせていただきます。
Now, myself, Maeda, would like to make some additional comments from the technical side.
地域それぞれのエネルギー事情という話がありましたけれども、例えば、ご存知の通り南米のブラジルでは、いわゆるカーボンニュートラル燃料としてすでにバイオエタノールが実用化されています。
So we did talk about different regions having different energy situations. To give you one example, for Brazil in Latin America, the bioethanol, a carbon neutral fuel, is already commercialized and used.
こういった地域ではですね、しっかりバイオエタノールに適用できる技術をですね、商品化するということが大事で、もうすでにトヨタはそういった対応をしてきております。
For these kinds of regions, for us OEMs, it will be important to prepare and develop the technology so that we will be able to adapt to the bioethanol fuels, and also to further to commercialize that. And Toyota has already been taking initiatives in this direction.
一方で、こういったバイオを使ったカーボンニュートラル燃料はヨーロッパでもバイオのディーゼルという形ですでに普及しているというよりは導入が始まっているという認識もしております。
On the other hand, for these type of carbon neutral biofuels, I also understand that in Europe there is the biodiesel that maybe not has penetrated too much yet, but I understand that the biodiesel has started to be introduced to the market.
また中国では水素を使っていわゆる FC をですね、フューエルセルを商用に 大規模に活動していくと、導入していくという動きがすでに活発化しています。
And in China, there is also an active movement of utilizing hydrogen for the fuel cell commercial vehicles. There is a movement to introduce these types of hydrogen fuels to commercial vehicles already.
レースの世界でもですね、e-fuel を使ってレースをするというような動きも出ております。
And even in the world of races, sport car races, there are movements to introduce the e-fuels to racing cars as well.
トヨタも日本では水素エンジンをレースに使っております。
And for Toyota, we have started to use the hydrogen engine in Japan for these racing cars.
なので、バッテリー EV を、ある程度コアというふうに捉えながらも、各国のこういったエネルギー事情、もしくはインフラ事情に合わせて、商品を具体的に投入していくという動きも非常に重要になるのではないか。それはトヨタ自身が開発をして対応していくものだというふうに考えています。以上です。
Therefore, I believe that while we place BEVs at the core of what we promote, in addition to that, we'll need to carefully watch the energy situation and the infrastructure situation of each country and be able to prepare and provide products, specific products, to meet the individual needs. So that will be important for us to do. Toyota will be working on development projects to be able to do that and also to deal with these different situations. That will be all. Thank you.
Okay, thank you, Claire. So we'd like to move on to next questions. Next question comes from the chat. The Ben Moyer, the two questions. The number one, can you quantify the degree of performance improvement of the bipolar nickel hydride battery used in the Aqua versus the previous generation nickel hydride battery? When was this new battery used in other HEVs as Prius, RAV4, Corolla, etc.? That is number one. And number two is when the first hybrid using the solid-state lithium-ion battery appear. I understand the solid-state battery could appear in the hybrid before a BEV. Thank you.
はい、次の質問はチャットからいただいています。ベン・モイヤー氏からです。2つあります。まず1つ目ですけれども、このバイポーラー、バッテリーのですね、この性能の向上に関してその度合いを定量化していただけますでしょうか。そして、これがですねニッケル水素バッテリーと比べてどれぐらい向上したのかということを教えてください。またこの技術がどのようなタイミングでハイブリッドに使われるのかを教えてください。もう一つの質問です。もう一つの質問はこの全固体電池が最初にハイブリッドで使われるのはいつになるでしょうか。そして私の理解ではこれはBEV よりも先にハイブリッドに搭載されると理解していますが、それでよろしいでしょうか。
Thank you for your question. My name is Kaita, and for the first question, I'll answer that maybe nickel bipolar compared with the existing current nickel metal hydride battery we are using, maybe almost the performance is increased up to twice. So, and maybe the next question is when the next HEV, which is equipping this new battery, is launched, and maybe it's very how to say delicate question, but probably very soon, but maybe next year or the year after next. And for your question number two, the question is maybe the all solid state battery will be used initially for the HEV. And this activity is in order to accelerate the development of all solid state battery. And maybe as we promised several years ago, this battery will be equipped on the vehicle maybe in the faster part of the 2020. And then maybe as we explained, maybe the performance of the all solid state is found that maybe this is very good performance it has, maybe for the very fast charging and discharging. So it is also a very good feature for the HEV battery. So maybe your understanding is correct. Probably we'll use the all solid state battery earlier for HEV than BEV. Thank you.
Thank you very much. So we are afraid our time is almost up. So we'd like to conclude this conference with the next question. So from Mr. Andrew Chan of T. Rowe Price. So please wait a moment while we switch your lines.
Thank you so much
for
taking my question.
Yep.
Yeah, I have two questions. First is, with a 1.5 trillion investment on the battery plants with your partners, roughly what % of battery cell economics will Toyota have on the 200 gigawatt hour by 2030? And the second question is, who ends up owning the patent on these battery investments? Because many of your partners also have partnerships with other auto producers, and they also have similar target of 50% cost reduction on battery cells. So I just wonder, is it the battery company that owns the patent and they just share it with everybody in the industry, or does Toyota have the patent, and is there any way we can gain some technological edge with this investment? Thank you.
はい、T. Rowe Price、アンドリュー・チャンです。私の方からは2つ質問をさせてください。1つ目が、パートナーと共に行っていく 1.5 兆円の投資についての質問です。この投資に関しては、経済的にそのバッテリーセルあたり、ギガワットアワーあたり、どの程度の投資になっていくのでしょうか。2030年までにはどれくらいの効果が、経済的効果が得られる投資になるのでしょうか。そして2つ目の質問としましては、特許に関してです。パートナーとともにそのバッテリーの開発に取り組んだ結果、その特許というのはどちらの会社が所有するのでしょうか。そのパートナー企業側でもいろいろな取り組みで 50% バッテリーセルのコストを下げるですとか、そういったことをされていると思いますが、最終的にその得た特許というのはバッテリー企業、専門の企業が所有をして、そして業界内で共有していくことになるのか、あるいはトヨタがこの特許を所有し、技術的な優位性というのを得ることができるのでしょうか。この2つをお願いいたします。
1つ目の方のご質問にお答えします。
So I myself, Okada, would like to respond to your first question.
この 1.5 兆円というのは、開発、それから生産設備、さらにハイブリッド用、PHEV 用、それからBEV 用、BEV 用と、これらを含んでおりますので、一概に1ギガワットあたりというのは出せませんが、少しご説明します。
So regarding your first question about the effect of this 1.5 trillion yen investment, so this will include the development investment, also investment for the production facilities and equipment, also the dedicated investment needed for hybrids, plug-ins, and BEVs. So this will all be included. Therefore, it's quite difficult to respond to your question about per gigawatt hour.
私どもは2030年に向けて200ギガワットの能力を確保して、でさらにこれをできるだけコンパクトな投資で競争力を上げていくと、電池コストも 50% 下げるというような、こういう目標も持っておりますから、そういう目線で1ギガワットあたりの投資についてもこれを小さくし、それを達成していくと、こういう考えで取り組んでおります。
So if I can explain a little about our approach to this investment, for Toyota, our plan is to secure 200 gigawatt hour of the battery capacity by 2030. And in doing so, we would like to make this investment as compact as possible, to make it competitive as possible, and also work in parallel the 50% reduction for the battery cost as well. So taking on approaching this investment from these various factors years, we would like to make the per gigawatt hour investment small as possible. So this will be the approach.
Sorry, I think the interpretation was wrong. What I meant was what percent ownership will Toyota have on the battery cell? Because you have 50% JV with Panasonic, so I understand Toyota will have 51% economics of battery cells. With future partnerships you are going to have on the 200 gigawatt hour, how much ownership will Toyota have? That was my first question.
失礼しました。Excuse me。通訳が間違っていたようです。すみません。私の質問と言いますのが、最終的にこの投資を行った上で、どれくらいの所有権を、この投資をバッテリーに対する投資をして、最終的にどの所有権のパーセンテージ、バッテリーセルに対する所有権は何%トヨタのものになるでしょうか。パナソニックとのジョイントベンチャーが 51% トヨタというふうな資本構成を理解していますので、そういったことを考えますと、この 1.5 兆円のバッテリー投資をしたときには、バッテリーセルの所有権は何%トヨタに残るでしょうか。失礼しました。
もし私の回答が不足でしたらちょっと補足またお願いしたいですけど、内製グループ、今おっしゃったようなパナソニックと一緒に作った会社、内製グループの会社、それから、パートナー企業の皆さんのところで作るライン、これらの設備投資についてはカーメーカーである私どもが負担をするということにしております。
So I will respond first, and my colleagues may further add some explanation. First of all, for the group companies of Toyota, we do have a joint venture with Panasonic, and we are working also with our partner group companies to set up these production lines for the batteries. And when we talk about the capital expenditures, the investments to set up these lines for the battery production, basically the car makers, we will be bearing the investment that is necessary to set up these lines.
従いまして、その投資をしたラインそのものについてはトヨタが持つということになります。以上です。
Therefore, for the lines that we have invested in to construct and set up, at the end, it will be owned by Toyota. So that will be my response.
For your question number 2, this is Kaita, and I'll answer you. Could you please look at slide 24? We will show that. This is the sum of the matrix. We are doing the test for the lithium-ion battery. At first, in order to run the lithium-ion battery, there are various kinds of the situation for the battery, because maybe for sensing the situation of the battery, we only can know the temperature or voltage and the electrical current. That is maybe very similar to that we are judging the health condition of the people by the temperature and blood pressure and heartbeat. So it's very important to make the model for the each part of the large section, cross section of the battery electrodes. And we have the more than 10,000 channels to test the battery. And this kind of the, maybe in addition to this kind of the experiment, please look at slide 23. This is a kind of the analysis or the development means we are taking. Maybe from the sub-nanometer, like maybe the atom scale analysis, to the very the large scale analysis we are doing for the in order to visualize that. And this kind of the experiment is, I think, taken by the most of the major battery suppliers. But exclusively, we are measuring and developing the measuring method by ourselves. And then please look at the slide 25. And this is a very typical, maybe the circulate of the experiment or development. Maybe we are taking the method of AI or material informatics. Also, maybe we are doing some kind of abuse test. There are many kind of abuse tests to ensure the safety of the battery. And please look at the 26. And also, maybe we have also the hills, maybe a hard loop in the loop system of the between the vehicle and the battery development. Actually, we have the some very unique usage of the vehicle, and from the vehicle we are taking the data, and precisely that data is introduced into the battery pack chamber, and maybe repeatedly completely the same condition is realized for this, and then. Maybe also maybe our feature is maybe we are developing this kind of test instrument by ourselves. And then please look at the slide 27. This is the number of the application of the patent maybe each year. Maybe Toyota and the Toyota Group is holding the more than the battery patent than the top patent holder of the battery manufacturer. I don't think this shows the height of the technology, but maybe this is the kind of the symbol that our engineers are maybe steadily making the great effort for finding the very, even the small improvement, we are steadily improve the battery. And then maybe for your questions, maybe when we develop our battery, the patent is owned by ourselves. And when we order some battery to our battery partner or maybe battery suppliers, at first we will show them the specification, which has to may satisfy our safety or quality standard. And then some of the parameters, if they cannot meet, then we will propose them the method to meet that. And then if they themselves can improve their features, then maybe the patent or such a maybe how to say the patent is held by them. But if they think that if our method we offer is acceptable for them, and then they use as is, then the patent is held by ourselves. And we have the very good relationship which respect each other between we and our battery partner companies. So maybe such maybe very fair the patent right is understood by themselves. Do you understand?
Yes, that makes a lot of sense. Thank you for clarification.
Thank you.
Thank you, Andrew. So that concludes today's Q&A session. If you require further information, please contact our IR representatives. Thank you very much for joining us today. Goodbye.